Let's evaluate the integral of product of x and sine inverse of x. Clearly we can see it to be a product of function. We see the integral to be product of x and sine inverse of x. We got two functions. Now we will apply product rule. Obvious question is which one should be the first function? Should sine inverse of x should be the first function or x should be the first function? To decide that, we got something called ILATE rule. So whichever comes first, we will regard it to be first. I stand for inverse, L for logarithmic, A for algebraic, T for trigonometric, E for exponential. Does inverse function occur? Does inverse trigonometric function occur? The answer is yes. So we will regard sine inverse of x to be the first function. So we will regard this integral as integral of sine inverse of x to be multiplied with x dx. Now let us recall what exactly is product rule. Product rule says integral of u times v dx, integral of product of u and v dx equal to first function, that is u, and integral of v dx minus integral of derivative of first function, that is u dash, times integral of v dx, and then this everything has to be integrated once again, that is the product rule. And so given integral is equal to first function u is sine inverse of x times integral of v dx, integral of x dx, minus integral of derivative of sine inverse of x, d dx of sine inverse of x, times integral of x dx, but whole expression, this product has to be integrated once again. Okay, sine inverse of x we can copy as it is, and we know that derivative of sine inverse of x is 1 by root over 1 minus x square. And how about integral of x? Integral of x to the power n is x to the power n plus 1 by n plus 1. We got n equal to 1. So x to the power 1 plus 1, which is 2, by 1 plus 1, again 2, minus integral of, once again, derivative of sine inverse of x is 1 by root over 1 minus x square, and integral of x is x to the power 1 plus 1, which is 2, divided by 1 plus 1, again 2 dx. Now we again see product of two functions, but we will not apply product rule. We can't apply it so many times, right? Somehow we should be able to integrate it. Sine inverse of x we copy as it is, x square by 2 we copy as it is. How about this one? Okay, let's do it separately. So we want to somehow evaluate this integral x square by root over 1 minus x square, but this, how can I evaluate it? See that if I write x equal to sine theta or if I write x equal to cos theta, then I can remove the root. Let's do it. So let x equal to sine theta. Then of course, then root over 1 minus x square equal to square root of 1 minus sine square theta, and that is just cos theta. Okay, but how about dx? So if x equal to sine theta, then dx d theta, derivative of sine theta with respect to theta, is just cos theta. So this integral is equal to integral of x square, that's sine square theta. What about the denominator? 1 minus x square, that is cos square theta, 1 minus sine square is cos theta, and 1 minus sine square is cos square theta, and square root of cos square theta is just cos theta. And then we can write dx is cos theta d theta. Okay, we can cancel cos as well. Nice. Okay, sine square, how can I integrate it? Okay, there are so many techniques. The easier one will be just writing sine square is 1 minus cos 2 theta by 2. That's the formula for sine square theta. Now, we know how to integrate half. That's half with respect to theta is just theta by 2. Integral of cos 2 theta is sine 2 theta by 2, but we got half as well. But we are starting with integral of x sine inverse of x, so we need to write everything in term of x. So this is equal to, if x equal to sine theta, then theta equal to sine inverse of x. So sine inverse of x by 2 minus 1 by 4 sine 2 theta. Okay, let's write sine 2 theta just for the time being as it is. So sine inverse of x, sine inverse of x by 2 minus 1 by 4 sine 2 theta can be written as 2 sine theta times cos theta. That's the formula. Sine 2 theta is 2 sine theta cos theta. So this is equal to sine inverse of x by 2. We can cancel 2 out, so half. Sine theta again, that's equal to x. Okay, sine theta is just x. What about cos theta? If sine theta equal to x, cos theta is exactly equal to root over 1 minus x square. So root over 1 minus x square. Okay, now can we get the final answer? The answer is yes. So integral of x sine inverse of x dx equal to, we got this expression sine inverse of x times x square by 2 sine inverse of x times x square by 2 minus half and then this integral minus half, then this integral, and this integral simply turns out to be x square by root over 1 minus x square. Integral of x square by root over 1 minus x square dx turns out to be sine inverse of x by 2 minus x by 2 root over 1 minus x square. Of course, after every integration we got some constant of integration. Let's simplify it out. Sine inverse of x times x square by 2. Let's write x square by 2 to the front side just to distinguish that x square by 2 is not part of this quantity, minus 1 by 4 sine inverse of x plus x by 4 root over 1 minus x square plus some constant of integration.